Hello, everyone, and welcome back to the course Dynamo from Zero to Hero, session number 3. Today, we have a new member joining us. Alex, I would like to welcome you.
Thank you very much, Nuhat. I'm quite excited to be here.
Yes, so today we are going, just to recap about the previous sessions, we are going to give some hints about filtering and cold blocks for this session. And for the previous sessions, we started with the user interface and introducing how could you cope up with a space in Dynamo and how could you use the nodes and all the options provided. And then we moved on into levels and lacing, and today we are going to talk about code blocks and filtering. So let's start with that. I will share my screen. And before we start with filtering and code blocks, I would like to talk about a very important topic in Dynamo, and it's called node status. And what I mean by node status, it means the different types of appearances that you will encounter while using Dynamo. The nodes could sometimes appear in different colors. They could appear doing different tasks. So it's really good to understand what each one is doing so that you can deal with it when you encounter it in the future. So as you can see, right now I'm using Dynamo Primer as my resource to explain to you this topic, and I'm inside chapter 3, 3.1, which is about nodes. And before I begin, if you were ever curious about how to research anything about Dynamo, it's always great to Google things. And I would like to show you how I came across this website and how I found it, because it's pretty simple. You always just go to Google and just type in, for example, my curiosity was about node status. So I just wrote node status in Dynamo. And then always the first link that you will find is from Primer. And this shows how important it is and how useful it is to always use. So that's what I used. And then it takes me to chapter 3. Of course, it will start with 3.1. And this is what we discussed in the previous session about what a node is and what are the inputs and the outputs. And then if I scroll down, it gets more in depth about what the inputs are and what type of data they require. And then I go back to what I want today. And this is exactly what I need. So I could start reading, I could start understanding the program much more by scrolling through these chapters and through the Dynamo Primer. And of course, you can always open just one link and then kind of scroll down and see all the other chapters. And under each chapter, there's a subcategory, so you can just explore that and try to understand it better. So let's start with the node status. From this diagram, that Dynamo Primer prepared 7 different states that a node could appear while using Dynamo. And it's quite straightforward. So each state is numbered from 1 to 7 in the image. And then down here, you have all the numbers explaining what each number is doing. So you can always read about that. But I will just go through one by one to explain to you in detail what each one is doing or what it means. So the first two states of a node, the first one is the active state, and the second one is the inactive state. And what do I mean by active and inactive? It would be much better if I go to Dynamo and show you an example. So right now I have two nodes, all elements of a category, and another node, element.geometry. You don't have to worry about anything right now. Just try to focus on how the node is looking like. Right now, my nodes, both of them, are appearing to be light gray, fully. There's no other color on it. And this shows me, and if I hover over them, you could see that I have a null value because it's inactive. There's nothing connected to it, no inputs connected, nothing is happening, haven't ran anything. So every time you see a node that is appearing like number 2, it means that it's not active, inactive. So that's a way to know whether your inputs are there. Do you have any wires connected or anything? So this is just an inactive state of a node. However, if I start to connect two nodes together, notice the difference. This changed from light gray to dark gray from the top. And when a node changes to dark gray, it means that it became activated, or that that it is ready to run. So if I run this, this should create something for me, or it would run the function that it's supposed to do. So that's the difference between being inactive and active. This one is still light gray because I don't have any input connected to it. So it needs a category input. So if I look for categories in my search button, and I just choose anything randomly, maybe floors, and then I connect my category to this one, it also becomes active because all the inputs are specified here and all the inputs are specified here. So they are all appearing to be light gray. So that's the difference between the first state, which is the active state, the second state, which is the inactive state. Yeah, so the third part is when a node appears to be red. And there are different reasons of why a node could appear red, but just a hint, sometimes the most common reason, at least for me so far, is when you use packaged nodes. And if I go back to Dynamo, what I mean by packaged nodes, we've already discussed this in the previous sessions, but there's a tab over here called packages. You can always search for a package and just type it in here and just download and install some packaged nodes that are created by other people and not by the Dynamo interface. So, so when you install anything from the packages or from the package search, you'll always have to make sure that they are updated or they match the version of Dynamo that you're using. Because if there is some nodes that need update and you open a script, you will find out one of them will be red, or it's telling you that, okay, this is a signal where you need to update your package. So it's very easy to update your package. You always can just search for it and then see which version you have. For example, let's say I want this one. I click on it and I can see that the only version they have is 1.1.1. Sometimes the most common ones, like for example, let's say Clockwork, you will see many different versions. Like so you have to make sure that you have the most recent one. So so just make sure you have that, and then you will be fine. Once you install it and then restart Dynamo, you will be fine. So that's why a node could appear as red, and red means error state according to Dynamo Primer. Now the fourth part, which I think is really interesting, is the freeze state. And I think this is really, really cool, especially if you have like a really large script and you don't want everything to be run at the same time. And what I mean by that, right now I have a really short script. I only have a category, which is floors. I'm getting all the elements of my category. And then in the end, I'm using element.geometry. So let me just run and see what happens. Just so I could start to implement the freezing option. It takes time because geometry. So right now I could see that Dynamo got all my elements of floors. So I have 44 floors in my project. And then it created geometry around each of these floors. So this is just geometry inside of Dynamo. It's not doing anything. It's not doing anything smart. It's just for visual reasons, just to show you the different ways of dealing with geometry. So right now, everything is being run. So every time I click run, all the nodes will be run, right? Now let's say I don't want any geometry. I will just disconnect it, but I still want them to be connected, and I want to save it, and then I want to open everything, but I don't want the geometry part to be run. I want Dynamo to stop when it reaches the geometry. So the way to do that is right-click on a node that you want to freeze, and then click on freeze. And now it's frozen. So now this node, if I run, this node will not create any geometry for me. And everything after this node will also be frozen. But right now I don't have anything after it. But let's imagine that maybe not this node. If I connect it to just any random nodes, but right now I don't seem to have, just anything randomly. Notice that anything that you connect from a frozen node to a normal node will also change to be frozen. because you're basically telling Dynamo, reach this node, stop, and don't run anything after that from that point. So, of course, this is not correct, but I just wanted to show you what happens when you connect things together. So now let's run. Everything is run. My category is specified. My floors are specified. But over here, even if I hover over it, usually when you hover over anything, you get the results. And if I hover over this part, I don't get any results because it's frozen and nothing is happening. No geometry is created. Now, that's the whole idea of freezing nodes and why to freeze them. You can always unfreeze things if you want your geometry back. So right-click again, click on freeze, and then it's unfrozen. So if I run again, I should get my geometry back. So yes, perfect. Okay, that's the idea of the fourth state, which is freezing. The fifth state is quite nice, I think, and this is just to show you what you select. So when you select a node, automatically a blue outline is surrounded by your node, and all the wires or the inputs that you connected will also turn blue. And for example, if I click on this node, see, it was normal, and then if I click on it, it will be surrounded by a blue outline, and this just shows that this is what you're selecting, and all the wires that are all the wires that are connected to this node will also turn blue, so the output and the input. And also, this could be really, really helpful when you have a huge script and everything is messed up, like things are on top of each other and you can't really see what is connected to what. You can just select this node, see that, okay, this part is connected and this part is connected, and the rest of the wires will be ignored because they wouldn't appear as blue. They will appear as black or dark gray. So that's the idea of the fifth state. Now, the sixth state is when you get a warning, and this will happen a lot. So always expect that. But for example, let's try to kind of mess this up and connect category to my element geometry. Now, right now, my element.geometry node expects an element. That's why I was connecting my elements here. However, if I connect a category, let's see what happens. And if I run it, I will get a warning, of course, because it is expecting an element, but I gave it a category. And always, when you get a warning in Dynamo, try to hover over this node that you get here and try to read what it says. It's not always the best description, I would say, but it sometimes gives you a hint of why or what's going wrong, basically. And right now, if I can read this, it expects this element.geometry expects argument types Revit elements, but was called with Revit elements category. So it was expecting an element, but I called it with a category. So that's, I mean, it explains it well, I think, for this case, but some cases it doesn't explain well, but yeah. So that's the whole idea of this state, which is the warning state, number 6. Now, the last one is when a node is in a background preview state. And if I run the script again to get my geometry back, and just wait a little bit. Yes, so right now I have geometry created in Dynamo, but let's imagine I want to run my script but I don't want to see any geometry. Even though I want it to run, I just don't want to see all the geometry that is creating for some reason. Maybe I just want everything to be cleaned and nothing to be shown. I just want the whole script to run without anything showing in the background. So the way to remove anything that's showing in the background is to click on the node that you want to not preview, and then go to this part. Right now, I could see that it's activated. The preview part is activated. If I click on it, it will disappear. All my geometry disappears and it becomes inactivated. And notice the color of my node becomes bluish, and that's just basically telling me that this is being run. Everything is perfectly fine. If I run again, it's fine. Nothing is wrong with it. Only thing is that it's not showing me any result in my background, which is more for visual purposes. So you don't have to worry about that. And I could always right-click again, activate the preview, and then my geometry appears back. And before we move on, just one thing I would like to mention. In your Dynamo workspace, you always have 2 types of backgrounds. The first one is a graph view, which is what we're in right now. It's a view that is showing me all my nodes. So if I zoom out and zoom in, it only zooms in and out on the nodes, not on my 3D. So because I'm inside of that space. However, I could switch into going to my 3D background space, and then all my nodes will become grayed out. They are still there. So if I zoom in and out, now it's focused on my geometry. I can just scroll around, rotate, and do whatever I want basically with it. And then go back to my nodes and continue my work. So that's just an idea of how to differentiate between each one of them and when to use them if you want. So since we went through all the different states of a node, if you have any questions, of course, post them in the chat. We will discuss them in the Q&A, but we could move on to the next part, which is code blocks, and it's going to be explained by Alex. So go on, Alex.
Thank you very much, Nuhad. If I just go on to share my screen now, I've prepared a wee preview to you about what different node blocks can do. But before that, we're just going to talk about what goes on within Dynamo that lets us use these node blocks. And for this, we have to understand what the programming language, the API, is of Dynamo. And it's called Design Script. It basically means it's the application program interface, which is the language we're speaking within Dynamo. And what is code blocks? Well, code blocks are our input into this here language, and code blocks are at the foundation of everything within Dynamo, and they really are your new best friend. You're never going to use a lot of the strings and a lot of the nodes that I'll show you in a wee while. Just use code blocks instead. The first simple inputs is how do you create a code block? Well, you just double click or you search for the code block in your library, code block, but double click and you'll get them as well. They look like this blank and they come with a standard null value, but we can enter things in here quite easily. As you see, I've just entered some numbers here right next to me. And as long as you know how to put your inputs in, you will get the right value. So you see me typing in 1 and a semicolon dot. This will give me the value of 1, and as you can see, it now gives me this value. This will essentially replace all your number inputs. You see that I've crammed all 4 together in one node instead of having 4 instances of the same node. Code blocks can also do other tasks that we ask of it. For example, it can do formulas, and I've put in quite a simple formula, 3.3 times 5, 15. We have the formula note as well, but as soon as you are using code blocks, you don't really need this. Mind you, you can put all of this in the same instance, so you get the you can cram all of this together in one code block. We can also give it values from the code block. So if you have booleans, and booleans is a simple yes and no question. It answers with a true or a false value. So if I am to ask you, Nuhad, are your name Alexander? You would say false. Whereas if I would ask myself that question, it would come out true. We can also make lists and make ranges within our code blocks. So you can see here a simple way that by just adding a couple of parentheses and a couple of dots, we're now making a list of 19 different numbers, whereas normally you'd have to use a range block, a range node, and 3 separate instances. But then you say, okay, well, a range node can have steps in them, and we can make these quite simple by adding another couple of dots and the step value in our code blocks. We also have we have a real popular node here called get item at index. So all the nodes that you normally use, all the everything fancy that you get within your geometry nodes and everything, these are still code blocks essentially that you can, the language they're speaking. So by doing some research into how to find it out, you can get the you can get your instance in your code block. I've set this here as an example where we've got a range that we used just before with steps, and then we have just written into the code block the list we want and the index, and it gives us the 13. Yeah, normally this would be achieved by a much longer list of nodes. With all of this, we are wanting to obviously make a script that we can use and showcase you, so you can take something away from this. I'm just going to start a new set here, and what we're going to work with today is the same project that was used the last time. So we have this house here that we're going to create. Last time you created views, and this here time we're going to create sheets. So we're ready for publishing. And what we want here is to search for sheet, and we'll scroll down, find the sheet by.
Try to add a dot, sheet dot, and then by. Yes.
There we are. There's two different here, and you can see that they're both expecting somewhat the same, but the first one is expecting views. So this is if you want to replace or place multiple views on a sheet. The other one is just expecting one view, so one view per sheet. We're going to use one view per sheet. You see, we have some inputs we need to fill out first. So using code blocks, we are quickly gonna set these up. We have first an A and a B, and this is essentially combining the two next to inputs that we're going to give it. So in another input or code block, we're going to create sheets for outline proposal, right? So I am going to give it outline proposal underscore home. Put this into A, and I want to make a range now, so we have a lot of different views that we can put on the sheets. So we are going to parenthesis 1 to 19, and this will give us the list of 19 different instances. So when we combine this into one here, we have.
I think you need to add them both, right? A plus B instead of A and B.
Yes.
Yes. So instead of specifying what is A and what is B, you can just immediately just add a formula where it combines them both together. Exactly. Yes.
Proper job. So this is our sheet number, and we also need to have our sheet specified. So I'm just going to do a family type. Do the K. This is selecting all the different types of families that I have in here. I want a sheet type, and click it into my title block. And last one is here. On to you, Nuhat.
Yes, okay. So let me share my screen. And right now, from what Alex was showing us, and as he explained, we are trying to create sheets in our Revit project. And we want to do it in a very automated way and a very fast way. Instead of having to create one by one in Revit, we want to do it in one shot inside of Dynamo. So what Alex was trying to do is to get the sheet number and the title block family, which he already did. So he specified all my sheet numbers, and the family, which is the title block A1, to use. And right now I will move on to tell you how to get the two rest of inputs, which is views and the sheet names. So before I do that, I would like to just go to Revit and show you what views I have, so you understand what I'm trying to do. Right now I have specific views in my Revit project that are called OP underscore and then the name of my view. And OP stands for outline proposal. As you can see here, they are grouped under outline proposal. And I want to put all of these outline proposal views onto sheets and then have them in my project. But the way that we were introducing earlier is getting everything, all the views in your Revit project. We never specified how to get a specific set of drawings or set of views inside of your Revit project. So if I go back to Dynamo, of course, the way to get specific things, there's many different ways, but the most efficient way is to use filtering. And that's one of the main things that I would like to explain to you today. So let's start to think of how could we find a way to get all our views and then filter them according to only get it, or filter them in a way to only get outline proposal views and then just place those filtered ones onto my view inputs. The way to do that, let's start as we always start with the categories, and I've already written it. I don't know, I think from the previous time, but categories, and we want our views. So I will just choose type in V on my keyboard and then just scroll down to get views. And I have the category, which is views, but I want the elements of my views. So I will just type in all elements and then of category, connect these two together, and now see how this will turn into dark gray according to the node status because the input is specified. And I want to run. But before I run, I want to keep running while I explain to you the process because it's much easier to see the results and to see what each node is doing. But I don't want Dynamo to run this node. I don't want it to create anything for me or to accidentally do anything. Right now, even if I don't care about this, nothing will happen because I haven't connected views and I haven't connected sheet names to anything. But let's stay on the safe side and let's say that we don't want Dynamo to run this. So if you remember from the node status, there is the fourth state, which is freeze. And that's what I'm going to do. I'm going to right click on it and freeze it so that every time I run now, everything will run except this node. And that's perfect. That's exactly what I want. So because I just ran it, I could just see that I have 77 views down here. And these are all my views in my Revit project. Now notice again, I have a null value, which always will pop up when you get a specific category or all the elements of a category. Now, I've already showed you a way to get rid of null values, but the way I showed you was using a package node, which caused some issues. And I was trying to wait for this session because I wanted to show you a way to filter it out, to filter all the null values using filtering. And because we specified this session to be about filtering, so you had to be a bit patient to wait for this session to know about the proper way of removing null values rather than packaged nodes. So the way I'm going to remove the null values is I'm going to use a node called filter by bool mask. And this node, to be honest, is one of the most common and most used nodes that you will ever come across. They're very, very helpful and really easy to use and understand. It appears to be a bit different than the usual nodes because usually any node has, some nodes have just one input and one output. Some nodes have so many inputs and then just one output. Usually it's always one output in the end. However, in the filtering node, in this node, if you notice, you get two outputs, which is not normal, or it's not the usual. So, and that's because those two outputs are what you're filtering. So whatever you filter will be separated into two different outputs so that you can just take the ones that you need and use them in your script. So that's the difference between this node and all the rest of the nodes. So let's try to understand what this, or how does this node work. This node works by filtering a specific list using Booleans. What do I mean by that? Let's start with the first one, list. I have all my elements here. This is the list that I want to filter, right? I want to remove all my null values. So this is what I want to filter. So let me just input that as my list. Now the second input is mask. And if I hover over it and try to read, it says list of Booleans representing a mask. So it needs Boolean values. Boolean means true or false, as Alex mentioned. And what you might be wondering, why does it need Booleans? I need to find a way for Dynamo to tell me whether the view at 0 is null, is it true? Or is it false, not null? So I need a list of values saying whether things are null or not null, and then I could use that Boolean list to filter data out into two different outputs. And let's use a node that automatically tells you whether something is null or not null. And the node is called is null. Very explanatory by the name. So what this node is doing is that if I connect my elements into my object is null node and I run my script and I pin my results, I can see that I get a bunch of true and false values. So the first item is true because it is null. So is it null? The node is basically telling me, is it null? True. That's true because it is null. And then the rest is all false because they are not null. So now I have a list of booleans that I could use to filter things. So to separate all my true values into one output and all my false values into another output. And I think that's pretty smart. This node is really smart because you don't only use it to filter nulls. You could use it to filter so many things. It's endless. But we are also going to filter other things, so just wait for it. So let me just put my Boolean list as my second input here, and let me run this and show you what happens. So if I just pin my results, I end up with in and out. So in list and out list. That's the same thing that you get here as your result. And notice in is separated than out. So they are two separate lists. So they are being filtered and cleaned or separated from each other so that you can use what you want. So everything that was null came under my in list, and everything that was not null came under my out list. You can always expand and collapse your lists. So that's the idea. The idea is to get a list with null values, filter it using Booleans, and separate them into two separate outputs, and then use my my output, which is out list, because that's the cleaned one without any null values. Use it in the rest of my script without any null values and without any errors, hopefully. So that's the whole idea of filtering nulls. If you were struggling to filter null values in the first session, just use the same concept, use these two nodes to filter things out, and then your script will also work without any packaged nodes. So that's that should help as well. Okay, so we're done with the first part, which is removing null values. Now we still want, we are still having a list of all our views, which we don't want. We only want the OP views or the outline proposal views. So we are going to use the same concept, filtering, but in a bit of a different way. So I will also, I can also search for it again, or I can just click on it, Control-C, Control-V. That's much easier to get it. And then I will just remove the inputs so that I could use something else onto it. So right now I want to filter again my views that were cleaned. So from the out, I will use the out as my list because that's what I want to filter. And I need another list of Booleans, but right now I need to think of a way to get a list of Booleans that tells me whether this view is OP or not OP, or does it contain OP or does it not contain? And the way to do that is using a node called string contains. And I really like this node because it really just gives you freedom to search for one specific part of a name or a view or whatever it is. It doesn't you don't have to write things exactly the same way they are. You can just use something that's a part of it, or search for a specific part of a view or an element or whatever that thing is. So let's try to discover what this node is doing. String.contain. String means text, as we always say. So I need a list of strings. So if I use my my filtered or cleaned views as my list of strings over here, and I want to search for OP. So as Alex said, we use a code block. So double click, and then I will just type in OP because that's what I want to search for. And then I will click run and notice what happens. I will get a warning. And this is quite cool because let's try to discover how can we deal with warnings, because they'll always pop up for you. So string contains expects arguments string, boolean. So it expects a string here, and a boolean here. However, it was called with Revit elements and then a string and a boolean. So I didn't give it a string here, I gave it elements. And now the difference between an element and a string, I think this part is really important because right now, my views over here, if I scroll to the side, I could see that each one has a green number or an ID. It's called an ID. And this is exactly the same ID that you have in Revit. So if I go to Revit, there is an option under the Manage tab. It should be this one. Is it?
Left.
Wait, oh, it's stuck now. But there is an option in Revit to select. Yeah, okay, now it's popping up. So to select a specific element by its ID. So I can always type in an ID that I want, and then I can search for the element in Revit using the ID. And that ID is exactly the same in Revit as what we're seeing in Dynamo. So Dynamo is telling me that floor plan OP_-1 basement has this ID. So this makes it an element in Revit because that's how it is specified as in Revit. So I cannot use an element to be presented as a string. I need to find a way to convert this data, which is elements, into a list of strings. And there is a really easy way to do that. We use string from objects. Oops, and that one. And what this node is doing is that it only needs objects. Object is basically elements, which is my views here that I have here. So my out, again, from the out list, these are the views that I want. So if I connect them here to my objects and I run, and then I pin it to see what's happening, it's giving me the same things. Everything is the same. Only thing is I am missing the green numbers at the end. All these IDs are removed because it's converting an element into a string format for me. And that's exactly what Dynamo is expecting in the string contains node, because it's only I could see that I was muted. I don't know which part did I stop at, but again, I can repeat this part just in case. So we had a list of elements over here, and this list of elements is basically with IDs, and I want to find a way to get rid of my IDs. So in order for me to use this data as a string, I need to convert it from an element to a string, and I use string from object node. If I connect my out list, which is the list that I need, my cleaned list of views, basically. And I run my script again, and I pin it. I could see the difference between these two views. They are exactly the same. Only thing is that the IDs are not there in my string list, which is exactly what I want, because then they are in a string format rather than an element format. So I could now use this as my string and try to run again, and my warning is disappeared because this is a string, and this node is happy because it's getting a string as it's asking for. So let's see what this node is doing for me now. It's giving me a true or false value. So what happens is that I specified my views over here, and I'm telling the node to search for OP. If there is OP, it gives me a true. If there is no OP in the name, it will give me false. So if I go back here to my views, I notice that the first few things in my list here are OP. So everything is true at the beginning. And then if you scroll down, everything becomes not OP. So everything else becomes false. So this means that what Dynamo is doing is correct. And that's exactly what I was looking for. I was looking for a way to get whether a view is OP or a view is not OP in a Boolean format. And that's what happened here. So now this is ready. And my list is also ready to be filtered. So I will just connect my Boolean list into my mask and run again and see how things will be filtered for me. So I also get an in list. And if I scroll down, I also get an out list. But right now, my in list contains only OP things or only OP views, and my out list contains everything else that is not OP. So that's what Dynamo is doing. Dynamo is separating all my views into only the outline proposal views and all the rest of the views into another output, which is the output. So my output is OP. So that's what I'm going to use to connect to my sheet node. So I will use my in-list views from here as my output and connect it to views. So all my views are ready. All my outline proposal are now filtered and specified by filtering, and I can just use it to view to the view input here. Now, only thing I'm missing now is element or the sheet name, and the sheet name is, everyone knows what a sheet name is. It's just the name that will appear over here when you create a sheet. And for me personally right now, there could be so many different ways of specifying the name of your sheet and what do you want your sheets to be named and everything. But for me, I want my sheets to be or to have the same name as my views. So let's say my view is called OP_1 floor. I want my sheet to also be called OP_1 floor. So how do I do that in a smart way? And how do I just get the name of my views and then use that name as my sheet name? There is actually a really cool node called elements.name. And it's expecting an element. And remember, these are elements because they have an ID. So this is perfect. I can use them, the OP views as my element. And if I run, and I just try to see what's happening, notice the difference between what it was before as an element with all the information, the type of view, the name, and the ID. Now it only extracted the name part for me. So everything is the same. It's only getting the name part. So now I have all my names ready. All the names according to the views is ready. I could use this same name or the names that I have. I could use them as my sheet names here. So I will connect them here. And that should be it for my script. Before I run it, I would like to just kind of go through it from the start so we could get a recap of what was happening and go through it a little bit more, because I know filtering could be a little bit difficult to understand at first. So in the beginning, we were getting all our views, all the elements of our views, and then we notice null values. In order to get rid of null values, we filter by Boolean using this node. And this node basically has two outputs, and those two outputs are because things are being filtered into two different lists. And I would like to group these two because these two nodes are doing my null filtering. So I will just select them like this, right click, create group, and then I will name it. If I double click over here, I will just name it filter nulls. And now it's kind of grouped. It's easy to move around and everything, and it's more neat. So it's quite nice. And then the next part that we did after we filtered out all the nulls and we got only the views that are proper without any null values, we filter again using a string contains node in order to get only the outline proposal views. So we search for only OP in our list of views, and then we get a true or false value, and we use that to filter our data basically. And also don't forget to convert your elements from elements format into a string format so that you could use the string.contains node. So I want to also group these two, so these nodes. So I will just select them, right click, create group, and name it filter OP. And yeah, and then the last part was to get the names. We don't need to group that. And then that would be also to do the sheet number. So I could also group that and call it sheet number. And then the family type or the title block is also quite fine, so we don't need to group that. And when you group things, you can always click on the group, right click, clean up layout, so it cleans up everything for you. I also like to do that all the time so that everything is cleaned up and everything is not messy anymore, and the space that you have becomes a bit less, more hectic. So that's quite nice. Okay, enough with the cleaning up things. Let's run it, and I will, before I run it, all the time I had, when I was running, I had my sheet node frozen because I didn't want it to mess up anything. I didn't want it to be run. I wanted to run it in the end, so that's why we froze it. So I will unfreeze it now so I could do that. So if I right click, freeze, then it's unfrozen, and it's appearing to be dark gray. That means that all my inputs are specified. I have wires everywhere, so it should be fine for me to run. So I will just minimize. And this might take a few seconds to run. Like sometimes it could take a minute because it's a little bit heavy, but we could wait maybe a little bit. And if not, we can just move on to the Q&A until it runs. Yeah. So do we have any questions in the chat?
We do have quite a good questions about this, because it is exactly what Björn is asking. If we can import data from an Excel, like sheet names and whatnot.
Yes.
And there is a really, really cool and easy way of doing this, because Dynamo comes with nodes that will tell you, specify a path to an Excel sheet and import it from there.
Yes, yes. I think it's Dynamo is also really well known. Other than managing data and doing so much automation, it's also well known to collaborate properly with Excel. And I think that's really, really helpful because we use Excel a lot in our industry, and it's really nice to kind of have this combination or the connection between Revit and Excel. So Dynamo is really great for that. So definitely you can obtain data from a specific Excel file and use it inside of your Dynamo and use it as sheet name or sheet numbers, of course. Sheet numbers right now, what we were trying to do is just to introduce the concept of getting a number. Of course, in reality, no one would do it that way, of course. You would follow some standards, or you would follow your company standards or whatever you're asked for. So you could do it in a smart way where you have it in an Excel sheet and then obtain it from that Excel sheet and then just specify it here as your sheet number. And also the same thing for the sheet name. And yeah, so I could see now that my script run is completed. So let's minimize and see that if we have sheets. And I will just expand, and I have all my sheets, and they are all OP, so only outline proposal. The sheet number is the same way that Alex specified. The sheet name is also the same way that I specified. And if I open some of the sheets, I can see that the name of my view is the same as the name of my sheet. And that's exactly what I was trying to do. And yes, that's the whole concept of today's script. It was to create sheets in one go inside of Dynamo from specific views that we filter out and to automate our process. Right now, what we were doing was just having 18 sheets. In reality, it could be like 100 sheets. So just imagine how much time that would save you and automate your work. So we hope that was helpful. So let's move on to the Q&A and see if anyone has some interesting questions, and we can address that.
Christoph has a good comment about how you learned the design script, and it's a really good way that you can go into Dynamo and ask a node to convert into its original language, which will become a node block, and then you can see kind of the workings behind it. And if you want to nerd out even more about some specific thing.
Yes. Actually, we could show. I could easily just share my screen again and show you what Christoph is doing. So you can always select. I'll just ungroup this. You can always select a group of nodes. Right click in space, and then node to code. And this basically is converting all these nodes into a code. If I click here, it will combine them all into a design script code where things are just coded according to the original language, or the way that, or the language behind every node. Right now, you can't see this language because it's presented in a visual friendly way.
It's presented in a way so everyone can more or less understand it. Like, it's giving you
Exactly.
element name, what is the element of the name, whereas if you would just read that in design script without
Yeah.
actually knowing it, it would be quite difficult.
Yeah, exactly. So that's a possibility, and I think that's what Christoph was trying to say. So thank you for that comment.
And I just did exactly what Björn was asking here on the side while you were explaining it. So I'll just share that with you as well. So here you see, Björn, that I've taken a file path. So I've taken an Excel sheet and imported it into Dynamo. And this is IDs that are already just from another project that is actually Revit elements. And you can select them with these as well. There's a way of matching a string to an ID. And that way you can select the actual item from Dynamo.
Yes, and I think so. This is the end of our session number 3 of this course. The idea was to create a very short course and a very basic course to introduce what Dynamo is and the possibilities of Dynamo. Starting from the next session, so we always host Dynamo sessions every second Tuesday. So the next Tuesday, it would be called Dynamo Tuesdays, and it will so stay tuned for that. The course is over, but we will still present some Dynamo scripts.
There's quite a lot in the works, right? We've got some interesting ideas about how to filter and how to sort stuff from Revit into Dynamo, and also create some mental geometry and whatnot. So the Dynamo Tuesdays are where we present what you have worked behind, not necessarily easily digestible and but it's to show the full capacity of what you can do
exactly
with it.
And we are always open to ideas if you're interested in certain things and how things could be done in Dynamo. Like, for example, Björn was mentioning how to get things in an Excel sheet. So maybe in one of the Dynamo Tuesdays we could go through how to use Excel sheets inside of Dynamo and how to get data from Excel sheets, which I think is super nice.
It is, and exporting there's a whole other world opening up with that.
Yes. So for Dynamo Tuesdays, stay tuned for that. Usually before the Dynamo Tuesdays, we have Dynamo Post-its, and this is more of a closed session where we, the Dynamo team, or the Dynamo Cafe team, we plan what we are going to present to you in our Dynamo Tuesdays. So those Post-it meetings are open for everyone. So if you are interested to join us there and to join our team, just send us an email and contact us. I will send all our contact information right now in the chat, so you can easily just send us a text or an email or anything over there. So if you were interested to join us on the planning sessions, you can always, of course, pitch in and join us there. And then we will present the Dynamo Tuesdays as normal every second Tuesday. So we are looking forward to the next session. So see you guys.
On the 3rd of November is the next Dynamo Tuesday. Before that, we are having our meeting the 27th. So make sure that you have sent an email if you've got anything interesting to showcase or an interesting problem for us to solve.
Absolutely. So thank you guys so much and see you next time.